Hello students. So in this video lecture we'll discuss chemistry chapter 4. The name of the chapter is structure of atom. Student, in this chapter we'll be discussing only the important topics, the important points. So till now we discussed about the atom. The matter is made up of atoms, the smallest particle. Now we'll see what is this atom actually made up of. Initially, the scientists thought that atom is the smallest particle, that atom cannot be further subdivided. But later on, their studies revealed that atom also has the internal structure. Atom is also made up of further smaller particles. So now let's find out what are the name of those particles. Student, atoms are made up of three fundamental particles: electron, protons, and neutrons. So electron, protons, and neutrons. These are the three fundamental particles that is present inside the atom. Student, here is a table to understand about these particles, the fundamental particles, about the electron, protons, and neutrons. Now, student, electron is a particle which carries the negative charge. So, electron is a negatively charged particle. Proton, it's a positively charged particle. Neutron has no charge. Neutron doesn't carry any charge. Student, electron revolves around the nucleus. Now, student, you can compare the structure, the internal structure of an atom with our solar system. Like our solar system have its central part, the center of the solar system is occupied by sun, and around the sun the planets revolves. Just like that, our atoms also have its center. The center of the atom is called a nucleus. The center of the atom is called a nucleus, and around the nucleus there are orbits where the electron keeps revolving. So these are called orbits. These are the orbits. This orbits is also called energy shells. They are also called shells. So in these shells or orbits, the electron revolves around the nucleus. So this is the internal structure. You can visualize the atom's internal structure like this. So we have electron, protons, and neutrons. Electron carry negative charge, proton carry positive charge, and neutron carry no charge. Electron revolves around the nucleus, and proton is present at the center called the nucleus, and neutron is also present at the nucleus. That means our protons and neutrons resides here at the center. So proton and neutrons is found here at this nucleus, and electrons keeps revolving around this nucleus. Now, student, about its discoverer. Electron was discovered by a scientist called J.J. Thomson. Proton was discovered by E. Goldstein, and a neutron was discovered by James Chadwick. Now, electron is the lightest of all the three particles. Proton is very heavy and it's approximately 1840 times heavier than electron, and neutrons have its mass almost similar with the proton. So proton and neutron have their mass almost equal, but the electron is lightest of all. Student, here is a diagram to show you how the electrons are distributed into different shells around the nucleus. So we have a number of shells. This is the first shell, this is the second shell, this is the third shell. The shell which is closer to the nucleus is called a K. The name of the shell is K. And the second shell is called a L. The third shell is called a M. And another shell is called, the fourth shell is called N. So these different shells have their maximum capacity. So now, to understand the distribution of electrons, let's try and understand the configuration, electronic configuration. Electronic configuration is the distribution of electrons into various shells of an atom. Now, to understand this, let's take the example of a sodium. Now, student, we know sodium have atomic number of 11. Atomic number is also called a proton, student. Atomic number is also called proton. Atomic number is also called a proton. So how many protons are there in the nucleus? This is the nucleus where the protons will be there. So we will have 11 protons of sodium present here in nucleus. So almost same number of neutrons will be present here in nucleus. So protons, as you know, protons are positively charged particles. So electrons will also be 11 in number. positive charge particle 11 and negative charge particle 11. Now proton is present here in the nucleus and electrons is distributed in different shells. So how they are distributed, student? So first shell have a maximum capacity of a 2. That means this first shell, the first orbit can take a maximum electrons of a 2, not more than that. Second shell have a maximum capacity of a 8. The second shell can occupy a maximum of 8 electrons and not more than that. Third shell either 8 or 18. So now student, if I want to distribute this 11 electrons in different shells, how do we distribute this? So first of all, we'll be filling the first shell. That's how we fill the orbital. So first shell will carry 2 electrons. Now we are left with 11 out of 11. Suppose 2 electron is given to the first shell. So we are left with 9 electrons. Now out of 9, the second shell can be given 8, its maximum capacity. So 2 given to first shell, 8 given to second shell, we are left with only 1. So that 1 electron will go to the third shell. So that's how we distribute the electrons. If I suppose take the example of a calcium whose atomic number is 20, means number of a proton is 20. So number of electron will also be 20. We can distribute the first shell, that is K, then L, M, N. Let's see, the first shell will be given 2. So out of a 20, 2 is given to this. We are left with 18. So the second shell will be given 8. So 20 minus 10, we are left with a 10. Now this shell will also be given 8 and the remaining 2 will be given to the last. So that's how the electrons are distributed into different shells. Now student, let's talk about the valency. What is the valency? The number of electrons present in the valency shell, or 8 minus number of valency electrons. Student, this is the first shell, this is the third shell, second shell, and this is the third shell. So in any atom, the last shell is called a valency shell. So in this case of a sodium, our last shell is M shell, that is called a valency shell. In case of a calcium, our last shell is N shell, so N shell is the valency shell. So the number of electrons present in the valency shell is called a valency, or 8 minus number of a valency electrons, or the electron present in the valency shell, is called a valency. Now take this example, sodium. So our last shell is KLM. So the last shell means M shell, that's a valency shell, carries only 1 electron. So sodium valency is 1. Now see student, chlorine. Chlorine valency shell is again M. So valency shell carries 7. So this time valency of a chlorine will not be 7, it will be 8 minus 7. It will be 1. Student, if any element have its valency electron, means the electron present in the valency shell 1, 2, 3. So valency will remain same, 1, 2, 3. Now if valency electron is 4, 5, 6, 7, 4 and above, so then to calculate the valency, we have to subtract the number of a valence electron from the 8. So 8 minus 4 equals 4, 8 minus 5 equals 3, 8 minus 6 equals 2, and 8 minus 7 equals 1. So if your valency electron is 1, valency will be 1. Valence electron is 2, valence is 2. Valence electron is 3, valence is 3. Valence electron is 4 and above, then only you will subtract the number of valence electron from 8 to get the valency. So in this case, 4 means 8 minus 4 is equal to 4, 5 means 8 minus 5 is equal to valence is 3, 6 means valence electron 6 means valency will be 8 minus 6 is equal to 2. Valence electron 7 means 8 minus 7, valency is 1. So valence electron and valency. I hope student you understood what is valence electron and valency. Student, atomic number, as I mentioned, atomic number is the number of a proton and is denoted by Z. And we have another number called a mass number. So mass number is denoted by A and is given by the sum of the number of a proton present inside the nucleus and number of a neutron present inside the nucleus. So suppose I have number of a proton 10 and number of a neutron 11. So what will be the mass number? So mass number will be the sum of the number of a proton and neutrons. So mass number will be 21. So this is how we calculate atomic number or mass number. Now, once you know the atomic number and mass number, the symbol, the chemical symbol can be represented like this. So suppose an element X have an atomic number of a Z and mass number of A can be written like this. So atomic number will be written at the bottom left subscript and mass number will be written at the top left superscript. So here we have an example. Suppose nitrogen atomic number is 7 and mass number is 14. So atomic number will be written at the bottom left and mass number will be written at the top left. Now suppose if I give you an element X saying that 6 here and 12 here. So if this symbol is given, you must understand the number which is written at the bottom left, that's atomic number. So this element have atomic number of a 6 and the number which is written at the top left, that's a mass number. So mass number is 12. So this element have atomic number 6 and mass number is 12. And you may be asked to identify this element. Now if you know the atomic number 6, atomic number of an element, at once you will identify this element. This element is a carbon. The atomic number of a carbon is 6. So I hope student, this was the introductory lecture where we discuss all the important points. So in the next lecture, we'll try and solve some of the important questions. Okay, thank you. Hello students. In this lecture, we'll discuss our chemistry chapter 4, structure of atom part 2. In this lecture, we'll continue with the isotopes and isobar, and then after that we'll solve some of the problems based on the previous discussion and today's discussion. Student, let's understand what is isotopes. Isotopes, atoms of the same element with different mass numbers are called isotopes. What does it mean? Means suppose you have an element, let's say suppose carbon. Carbon is an element. Carbon have a two different type of atoms. This is one carbon atom, this is another carbon atom, different type of carbon atom. When I say different type of carbon atom, it means they have the same atomic number but different mass number. Atomic number is same. You can see here both these atoms have a atomic number 6 and mass number 12 and 14. So these two atoms belongs to carbon element. That's why they have the same atomic number, because they belong to the same element, but the mass number is different. So such atoms which have the same atomic number with different mass numbers are called isotopes. So here are some of the examples: carbon and chlorine. Chlorine is one more example. We have atomic number same, mass number is different. So these are the isotopes of a chlorine. Student, there are important isotopes of hydrogen. We have three different important isotopes of hydrogen. This is 1H1, that's a protium, 1H2, that's a deuterium, and 1H3, that's the tritium. Isotopes have the same chemical properties because of same number of electrons. Student, elements have their chemical properties same if they have the same same number of electrons, or we can say the chemical properties of elements is decided by the same number of electrons. If they have the same number of electrons, they have the same chemical properties. Let's say suppose this carbon 12 and this carbon 14. Carbon 12 and carbon 14 have the same chemical properties because these two have the same number of electrons. That's isotopes. Now isobars, atoms of the different elements with the same mass number. Student, this is just the opposite of isotopes. In case of isotopes, it was the two atoms of the same element. But in case of an isobar, we have two atoms from the different elements but having a mass number same. You can see argon is the atom of argon, is the atom of a calcium. They have a different atomic number because they belong to different elements but they have the same mass numbers. So such atoms which have a different atomic number but same mass number is called isobar. So example of isobar, we have argon and calcium. So these are the today's discussion, student. Now let's move on to study to understand some of the problems based on our previous discussion and what we have discussed today. Student, this is the first question. Z is equal to 3. Now you know what does it Z means. Z stands for atomic number. This is the symbol of atomic number. So atomic number is 3 of an element. What would be the valency of the element? We have to find out the valency of this element and we have to identify the element. We have to name this element. Now Z is equal to 3 means atomic number is 3. And students, you know atomic number is also equals to the number of a proton. And number of a proton equals the number of electrons. So if atomic number is 3, it means number of proton is 3 and number of electron also 3. So now I know this element have electrons, number of electrons 3. So we'll write the configuration of this element. So we'll get the configuration 2 1. That means the first shell, that is K, second shell L. First shell will get 2 electrons and the remaining electrons will go to the last shell. And you know, student, what is valency means? Valency is the number of electrons present in the last shell, or number of uh, electrons left after subtracting from 8. So we have 1 electron in our last shell, valency shell, so our valency is 1. And student, you remember atomic number 3 means element is lithium. Lithium's atomic number is 3. So that's how we can solve this problem. Let's understand one more problem. If the number of electrons in an atom is 8 and number of a proton is also 8, then what is the atomic number? What is the atomic number and what is the charge on the atom? Now student, number of a proton is given to us as 8, and as I mentioned, number of proton is also equals to the atomic number. That means our first answer is atomic number equals number of a proton, that's 8. So first question is answered. What is the atomic number? Atomic number is the number of a proton, that's 8. Now the charge on an atom is at 0. This atom will not have any positive charge or negative charge because we have the same number of protons and electrons. That means you have a plus 8 and minus 8. 8 proton means 8 plus charge and 8 electron means 8 minus charge. So because the charges are equal and opposite, they cancel each other and gives us the net charge 0. So this atom will not carry any positive charge or negative charge. So that's how we'll solve this problem, student. Student, here is one more problem. Composition of the nuclei of the two atomic species X and Y are given as under. X and Y, number of a proton 6 and 6, number of a neutron 6 and 8. That means this species X have a proton 6 and neutron 6. This species Y have a number of a proton 6 and number of neutron 8. Give the mass number of X and Y. What is the relation between the two species? Student, this question, two parts there. We have two parts. The first part is to find the mass number of X and Y, and the second part is to identify the relation between the two species, or this, how do this X and Y relate, or can say related to each other. Now student, first part of the question is to calculate the mass number. From the previous discussion, you know the mass number is calculated like this. Mass number, the symbol of a mass number is A, P stands for a proton, number of a proton, and is the number of a neutron. So total number of a proton and neutron gives this a mass number. You see, if I want to calculate the mass number of X, I must know the protons of number of a proton in X and number of neutron in X. So I know the number of a proton 6, number of a neutron also equals to 6. So mass number of X is proton plus neutron, which is 6 plus 6 equals 12. So that's the mass number of X. Now Y, proton plus neutron 6 plus 8 equals 14. That's the mass number of Y. Now if you pay attention, student, proton, X proton is 6. We can write like this, X proton is 6 and mass number is 12. So in case of Y, we have a number of a proton 6, mass number is 14. If you remember, we have studied about this type of species. The atoms with the same atomic number but different mass number, they are called isotopes. That means this X and Y, they are isotopes. That's how they are related. I hope, student, you understood these three problems. So we'll end today's discussion. Thank you.